Video we are going to discuss how to create a segment tree. So segment tree is a data structure which can be used efficiently in order to do queries like where you want to find something in a range of interval. So let's say you have an array from 0 to n and there are two indices, left and right, where left is less than right. So and you want to find, let's say, what is the sum of all the numbers in that range, or uh, what is the what is the product of those numbers in that range, or what is the GCD, and along with like finding doing this operationals query, let's say you want to do an update on a certain range. In all those situations you can use a segment tree. So that's the general idea behind it. You can go to and go and ask chat gpt in order to find what are the other applications where a segment tree can be used. So let's go through this particular code here in order to understand how to build a segment tree. So let's say this is the class, right? Okay, so class will be having an array initially, and we have to transform this array in a segment tree. Okay, so by analysis we know that if you were to perform an analysis how many nodes are there in a segment tree, you will find out that at most it will have like 4 times the total number of nodes in the actual tree. And then what, so let's create another array, self dot segment tree, which will be initialized to the 4 times the length of the original array. So, and then it will go to the method self dot build tree. Let's go to self dot build tree in order to see what we are doing here. So if we are in this method, you'll notice that we have three indices: node, left, and right. So node basically represent the current node which we are at, and which where we are trying to build that tree. And then left and right is the range of the intervals which this particular node holds. So if left is equal to right, then you can simply assign, so left equal to right means that this is a leaf node. So in that case what you can do is that you just simply assign whatever the value is back to the node, and then you return from there. Otherwise, if it's not a leaf node, what you do is that you find a mid element, and then you call this entire method again on that using the new left and right values. So this mid will give you the interval which the original array is holding. So what you will do is that so for getting the left node for the segment tree, it's simple, right? So if the tree is 0 indexed, the left node will be twice the index value of that one, and then we add one, right? So if let's say if the tree was at 0, then the left node will be 1 and the right node will be 2. So this is the formula for getting the indices for left and right node in the segment tree. And then coming to the interval that we are trying to store, we have just calculated the mid value, all right? So we pass those left and mid value, and then mid 1 plus right to this same procedure again. And at the end what we do is that now, since we have a segment tree built on these two nodes, and we want to create a segment tree which has to store sum. So what we do is that we simply, like at the current node, since we have the values at left and right child, we simply take the sum. So let's say if we were to build a segment tree which can hold a GCD, so in that case this will be replaced by a GCD operation. Had we tried to do a product binary tree, we could have used product here, and so on and so forth. All right. So that's the build tree portion for our code. The next query is that now let's say you have we have a query interval q left and q right, and we want to find out what is the sum of this particular sum of the values in this particular range. So how do we do that is that we have created this another method here which is taking 5 parameters. So if I were to go into this method, we will see that the first parameter is the index of the current index in the segment tree, and then t left and t right denotes what is the range of interval this current node is holding, and q left and q right is our query. Okay, so the first condition is, so let's say if the right index for the for the query interval, if it is less than the t left, or if the left index for the query interval is greater than the right index of that particular tree. So in this case, so basically what is happening here is that whatever the interval the current node is defining and whatever we have in the query, so it is either falling to the left or to the right of that current tree. So in that case we just simply return 0. Otherwise, if let's say if the current interval, right, so tree left and tree right, if it is within the range of the query interval which can be seen by this particular condition, so we see, right, tree left and tree right are basically within the bounds of our query. So in that case we have to return whatever that node is containing. All right, otherwise what we do is that we find out the mid. So if this is not the case and this is not the case, then it is a case of partial overlap. In that case what we do is that we find what is the mid. All right, so mid in the sense like we want to break the current interval. All right, so we break the current interval and then we find out what is the sum of range between the new index, and then we update the new intervals and pass on the query and return the total sum. Okay, so this is about finding the sum of a range. The other type of query that we have is basically updating the values in that array, right? So there are 3 simple methods here. So the first step is we get the difference, because this difference will be used then in order to update the segment tree. So what we do is that we get what is the new value and what was the older value at that index, and then we store it in difference, and then we update the original array here, and then we call this method update tree. So what update tree is doing is that if you were to go in update tree, it is taking 5 parameters. Okay, so the node left and right are the usual meanings, where node is the current index, left and right are the intervals which that node is holding, index is the index of index where we want to update the value. So what we do is that we simply perform this check if the index is out of bounds, right? So if the index is lower than whatever the index we have currently in the node, then, or if the index is greater than the whatever the right value of our current node is, then we simply return. Otherwise what we do is that we update the current index by the difference, and then we check, and then we see whether it's a leaf node or not. If it's a leaf node, then we return right then and there, right? And if it's not a leaf node, what we do is that we again calculate the mid, and then we call this procedure recursively on our new values, where we have the usual code, right? So it will be the index of the left node and then the right node with the updated values of the intervals that we have in those nodes, and then we pass on these values. So yeah, that's the entire segment tree. Thank you.